into product research industries and more. So that's a little bit about me. I was actually no slide for that. I just kind of jumped into it. Let me introduce Brad, who's with me. He's one of our senior account executives here at MarkLogic. So he's the guy you should be talking to if you really like what you see here and you need a demo taken to your company or you need more information about the product.
Absolutely. I'm based in Austin. I cover San Antonio, Austin, and Dallas. Basically, I call it Fortune 500, but it's the whole commercial sector for the San Antonio, Austin, Dallas market. So, been with MarkLogic just a brief period of time, but I kind of echo what Rob said. There's an enormous amount of excitement inside of our company. We've been around since 2001, so we're not a new company. We're not a startup. If you're not familiar with MarkLogic, I think what Rob is going to present to you today is going to be kind of a mind-bending, kind of I just got back from Disney, so maybe a Twilight Zone kind of experience for you about ways of looking at data inside your enterprise. So with that said, I'm the sales guy, I'm not a technical guy, so I don't want to sell you guys today. So I'm going to turn it over to the expert, to the technology expert, and let him do his thing. So I've actually got to cut out and get back home before Rob wraps up, so I'm going to quietly sneak out. But we've got some material over at the end of the table here, and I also have left some of my cards on the corner as well. So if anybody would like to follow up and have conversations, I would be more than happy to pull the appropriate resources together to really give you a deep dive into what it is we do. Okay. Thank you.
Thanks, Brad. So with that in mind, I'll get started. The first slide I had was just a little slide about me, but I think I covered that kind of out of order. But basically, I've been with MarkLogic for about a year now. I've been working with the technology for about 2 years. Working with the technology really changed the way that I look at data, and hopefully I can change the way that you look at data by talking to you about some of the different modeling techniques and some of the different analyses that are out there for working with data. So here's a quick list of things I've done since coming to MarkLogic. I was with Monsanto as my client for the last 8 months. I'm currently consulting with the American Hospital Association. Before that, I worked with Fortune 500 product research startups. I've also helped out with various POC, proof of concept projects, and various engineering challenges across the company as well. So I've made a lot of contributions. I'm pretty familiar with the technology, so don't feel afraid to ask me anything too technical. I'm more than happy to take it and try to answer it. Feel free to stop me if you have any questions. So this is kind of the agenda that I put together for the presentation. So if I'm going to talk to you about modeling data and looking at your data differently, I'm looking at this from the perspective of someone who works with and uses MarkLogic every day. So I'm going to need to give you kind of the quick 5-minute sales pitch on MarkLogic and just kind of what we do and how we do it. I'm not really a seasoned speaker. I'm not a sales guy. So I'm really just going to try and give this to you from the position of a developer and the features that I think about and use when I'm looking at data and looking at data modeling problems. After that, we'll do kind of a quick data modeling thought exercise. We'll look at a problem, we'll look at how we typically model it in a relational world, and then look at some of the problems that come with that, and then look at how we would model that in a NoSQL world instead. After that, we'll pivot and we'll talk about something called the semantic data model, which is probably going to be new to most people in here. This is really where the mind-bending things that Brad alluded to come into play. After that, we'll talk about, very quickly, MarkLogic's search query and application services features, which can be built off strong data models, and then we'll look at some use cases, and finally I have a couple of demos for you. So with that in mind, let's run through it. Feel free to stop me at any time if I say something that you don't understand or if I'm talking too fast. My director of engineering, when I was driving this presentation, he said, whatever you do, don't tell the audience you're nervous. I'm not going to do that. Just tell me if I'm talking too fast. Okay, so this is how our marketing presents MarkLogic. So we like to use the term that we're an enterprise NoSQL database. But really, we're not really an enterprise NoSQL database. We're more than that. We're an enterprise NoSQL platform. So MarkLogic kind of sits in the center of 3 different silos. The database silo, the search silo, and the application services silo. The database is a NoSQL database that stores XML and JSON natively as its data model. It's essentially a document database that stores information as hierarchies. On the search side, MarkLogic has a search engine baked into it from the beginning. Since our founders started putting the software together, he began indexing all the data that went into MarkLogic and making sure that it had Google-like search and query capabilities built into it. And finally, we wanted to make sure that this product could implement easily with other existing systems and upcoming applications and platforms. So we built in a lot of features like REST APIs and Java APIs and Node.js client APIs to make that as easy as possible for you. So we'll cover some of that a little bit more towards the end of the talk. But the reason why we use the term enterprise NoSQL versus just NoSQL is because MarkLogic is really the only NoSQL database that I'm aware of that has a lot of features that enterprises need to depend on. These include things like ACID transactions, high availability and disaster recovery and replication. It has security that the government uses and relies on regularly. It scales well, it's very elastic. You can deploy it on cloud or on a physical machine easily. You can even integrate with Hadoop and other enterprise technologies that companies are using widely today. So there's really no other platform that at least I'm aware of that can claim to have all of those features and bring it all under one roof without having to sell you multiple products and services. So what is enterprise NoSQL? Again, enterprise refers to all these trusted features that we come to depend on, and NoSQL expands that out with things like powerful storage of a different data model and agility to be able to very flexibly develop applications upon it and build out new software quickly across your enterprise. I know that this chart is kind of an eyesore. There's too much to take in, so I'll finish with this chart so we can go through it more later. But I don't want to take up too much time with it. How we position ourselves in the market is we really think of ourselves as a new generation of database. So we start with sort of the mainframe era. So IBM dominated that area. IBM had all the big mainframes and they stored data in kind of a hierarchy. But the problem with this era was that data was very hardware specific. So your data model determined the kind of hardware that you had, and it wasn't particularly flexible for changing data models. So then, we came to the relational era, the SQL era, as we like to say. And Oracle has dominated this area for a long time. And Oracle said, it doesn't matter what kind of hardware you're running, as long as you have structured data, we can take it and we can give you the ability to query it. And that's great, but sometimes structure changes. Structure isn't something that stays consistent, and structure isn't necessarily something that plays well with other structures. So now there's been a new generation of databases coming forth, and this is the NoSQL generation of databases. You've probably heard of other databases like Cassandra and MongoDB and Memcache and Redis and things like that. And they all have these different underlying data models. Some of them, even though they call themselves NoSQL, do allow you to query them in SQL. But what fundamentally separates these from other databases like Oracle and Microsoft is that they're not using a relational model under the hood. There's no tables and columns, even if they let you use things like SQL to query them. And MarkLogic is one of these databases. We're hoping that MarkLogic is going to lead the NoSQL generation to new heights by being an enterprise-class NoSQL database. So these are some of our featured clients. I've worked with Monsanto extensively over the last 8 months, but I'm also going to talk about some of the other clients when I get to use cases at the end. The one client I do want to point out now is healthcare.gov. We are the main database backend for healthcare.gov. Healthcare.gov runs on our NoSQL platform and not a relational platform. And if you think about all the different sources of data that they're trying to blend together from all these different healthcare providers, then hopefully you can kind of see the ways that we're going to start talking about how you change how you think about data. So let's do kind of a data modeling thought exercise. So you come into work and your boss tells you that you need to put together a new database schema for your employees. And he says, I want to know where are the name of my employees, where do they live, and we're a car company, maybe we're Ford, maybe we're GM, but we want to know what kind of car people drive, because we want to know how many employees are loyal to our brand. So this is probably the first attempt at a relational schema you would come up with. So we have a primary key, we have the name of the employee, we have their address, and we have their car type. Now we've asked our boss, do you care what make and model it is, do you care what year the car is? And he just says, no, I just want to know if it's our brand or if it's an Acura, a Chevy, something like that. Then you build an application on top of this database schema that you built, and your boss is getting all of his questions answered, and then he decides, I have new questions, new requirements, new schema. How many people have dealt with this before? Okay, awesome. So we all feel the same pain together. This slide actually makes me feel physically ill standing up here. And the boss says, you know what, I changed my mind about the car. I want to know the make, I want to know the model, I want to know the year, I want to know specifically what they're driving it and how long they've owned it for. And you know what, I want to know who's most loyal to us and which states they're in. Are our New York employees more loyal to us than our Texas employees? And you know what, give me the zip code too, because I think I might want to know even more granular detail on their location. So we redesigned the schema like this to accommodate all these new fields. And you're going to notice that I've replaced car type with car ID because we're just going to assume that there's a car table out there because multiple employees may drive the same type of car. And then, now we have another problem on our hands. Okay, we fixed the schema, but how do we update the application that we build on top of this? So there's really two things we can do. We can update the schema across the database, but then the application's going to break. Or we can update the application, but then the application's not going to be getting any data from the schema because the schema hasn't been updated in the database yet. So people usually handle this in one of two ways. One way that they handle it is they do a kind of like a mediator schema, so they'll keep all the old fields, they'll put in all the new fields, then they'll update the application, and then they'll get rid of all the old fields. And that's just really a headache, and everyone in the development team needs to be aware of that process to make sure they don't delete a field too quickly. Or the other way that people handle this is they build the whole application, they run it in parallel with the old application, and then once the new application and the old application are running in parallel, they kill the old application, and then the new application becomes the new application. Either way, this adds time, complexity, and headaches that you just don't want to deal with when you're doing this kind of development. So, finally have a good schema, right? But the problem with this is that you have to get the model right the first time, because otherwise you're going to keep changing your schema again and again and again. Now, what happens if your company opens up operations in London? Well, guess what? I hope you didn't use a schema type for zip codes that was 5 digits, because people in England use alphanumeric characters and numbers. We have the same problem again. What if we want to distinguish now between full-time employees and hourly employees? Maybe we need 2 different tables now for employees, and maybe we need some kind of table in between them to manage the relationship and show that they actually are an employee. So the growing question I'm getting at is, how do you manage the growing needs of a database within a company? How do you come up with a model that is going to suffice all of these needs, and you're not going to have to worry about flexibility? You're not going to have to tell your boss, no, I can't get it done next week, I have to get it done next month, because of all of the complexity involved with this. And surprisingly, there is actually a way to do this. So, but before we jump to the punchline and I show you all the tricks, let's do one more data modeling exercise. Let's play a game. You have to design a schema for a book. And books, not that hard to fit into a schema. A book looks like this. We have a lot of information. We have a title, we have an author, we have different chapters, and we have maybe sections within the book. Like this is section 1, 4 chapters, section 2, 4 chapters. We may have things like forewords in the book. We may have things like editors as well as authors. So maybe we come up with a very simple schema like this to try and represent this. Title, author, section, maybe a table for chapters, a table for sections, things like that. But then, of course, like I said, these questions come up. How do we handle bibliography? Is a forward different than a chapter? Does that need to be modeled in a different data? Does that need to be modeled in a different table? What about indexes that may be in the book? What if the book has multiple authors? We need to make sure that the author field is a list rather than just a single author or an ID. But what if we start the book a little bit differently? What if we take kind of the natural structure of the book, the natural hierarchy that's there within the book, and we just keep it as it is? And what if we take this hierarchy and we put a little bit of structure around it, just a little bit? That looks familiar. That looks like XML. Yeah. Who here is familiar with XML? Great. This is my audience. And everyone else is familiar with JSON too? Okay, because we all know that JSON and XML both represent hierarchies, so we can do this in JSON just as easily as XML. So that kind of leads me into my segue. Let's actually talk about how document databases model data and how they think about data differently. So noSQL can work for relational systems, or at least noSQL in the document sense can work for relational systems. Hierarchies are very natural. Human beings tend to think in terms of hierarchies. If we're looking at a corporate ladder, we're thinking the CEO's up here, the executives are down here, the low-level employees are below the mid-level managers, things like that. If we're looking at financial trading data, which I did a lot of when I was back at that energy company, we know that you have a trade, which is kind of your encapsulating everything, but then you have counterparties within that trade. Counterparties themselves have certain properties. Trade details, such as where the trade was made and when the trade was made, may have details too. And so we, as humans, tend to organize things in terms of hierarchy when we're thinking about entities and objects. So, MarkLogic, schema-agnostic database, that stores JSON and XML natively. So this piece of XML that we're looking at, this is what we call a suspicious activity report. This is an example that comes from some of the work that we do with some very shadowy 3-letter organizations within the government. So this is just a very natural document that went into the database. So this is a suspicious vehicle near the airport. This is the date it was on. This is the type of threat that was there. This is the location where it occurred. This is some information describing what happened. And you'll see something at the bottom that says triple, and we're going to talk about that soon. But for now, I'm just going to show you the really cool animation. This structure fits very well into a hierarchy. And what also makes this interesting too is that you can kind of see as a hierarchy. If you need to add a second location, or if you needed to add more information here, you can really just put it in the tree wherever it needs to go. You don't have to think about schema because schema isn't defined here. Schema is whatever you choose to make it be. That's schema agnosticism. So this is JSON, same beautiful animation, same idea, everything's stored in a hierarchy, very impressive. And then documents can have different data types within them. You just choose within the element. So here we have unstructured full text within the description element of the suspicious activity report. Here we have a date. Here we have geospatial information, a latitude and longitudinal coordinate pair, specifically where the incident occurred. We have something called semantic or RDF triple data, and that's going to be the subject of the next part of this modeling exercise, so we'll get to that shortly. But basically, you can think of that as being like nodes in a discrete mathematical graph. So let's talk a little about the methodology behind hierarchies of document stores and how data gets denormalized. So we looked at books, and we looked at how we might model these relationally, and we looked at how we might store these in different tables. This could be essentially a SQL schema or a relational schema for a book. But in the document world, we don't really do that. In the document world, we think about things as hierarchies. So we don't separate, disjoint rows of information across different tables. We put it all under one roof. So you can imagine me, sticking my hand out, pulling like the ID row from that book, and then just kind of pulling it out, and all these little strings are attached to it. They go to the other IDs, and out pops all the data. So it's very easy to kind of take your relational model that already exists and transition that into kind of a denormalized document model. I had some notes here, but I can't remember what this was. This one delivered in the presentation. Okay, so let's talk about expansion across your database. So as your database grows in size, performance is going to slow down. You're going to need more storage, things like that. Traditionally, the way that relational systems handle storage is they tell you to buy more hardware, they tell you to buy more storage, and they tell you to make your systems bigger. But don't add more systems, just take the one you have and make it bigger. Keep all the data on one system. With a document database, you can expand horizontally rather than vertically. So we've got multiple systems here, and we can scale out with them. So rather than keeping all the data on one roof, we're going to put it in the roofs of multiple systems. So why do NoSQL document databases do this and not relational systems? And really the problem here is sharding. So I don't know how many of you are familiar with sharding, but the basic idea is that in order to maximize performance on a relational system, you want to limit the amount of joins that get done across the network as much as possible. So if you're going to be joining a row with another row, you want those two rows on the same system. Otherwise, requests has to be made across the network, and that's going to slow down time. So how do you handle sharding? Do you just put tables on one system? Usually people just put subsections of tables that relate to each other on the system to maximize performance. But it's a headache. You can never get sharding done right perfectly the first time. And sometimes you can't even get it done right the third or fourth time. But document models handle sharding differently. With document models, you're just taking the entire document, you're storing it on the system. So you never have to do that kind of inter-system join. All the data is in the tree, and it's just sitting there. So you may have to query multiple systems to find all the documents, but you have to do that with SQL anyways. All the data is sitting there on one machine without having to do a join between multiple machines. So this enhances performance. This puts the query or the evaluator node in one place. So document modeling is progressive enhancement. So essentially, it's more flexible and it's more easy to get started with data and to limit the amount of modeling that you need to do before actually implementing an application or something like that. So there's some beauty with document stores. There's no tables. The modeling is simpler. You can get started today, and if your model changes or the data changes, you can work with it right off the bat. To that end, data just ingests in the document stores as is. It keeps its natural hierarchical structure, and it stays just as easy to work with as it used to.
So are you saying document modeling is better suited for unstructured data?
Absolutely.
Okay.
So I'll give you an example of a customer that I work with.
You're not suggesting that structured data also could be modeled in a document format? Or
Yeah, structured data could be modeled in document format if you needed to. If you were going to start adding unstructured data to your structured data that already existed, there's a lot of benefits that could be had by actually just moving entirely to a document model, because then you've got a database built for that unstructured information out of the bat. Or sometimes we see other people keep the structured information in a structured system, but just link it to an unstructured system and manage that.
Okay.
Do you want to actually query and analyze the unstructured information, or it's pass it in an unstructured system?
Okay.
So the next thing that document stores do that's really, really useful is they index everything, especially MarkLogic because it's a search engine built in. It'll index every different type of value within your data to make it really easy to query and search and traverse the data. And finally, document stores, as we talked about with sharding, are much more elastic than relational systems. Not only can you scale up, you can scale out. This gives you a lot of room for optimization of your document system, document store. So now I want to completely pivot from document modeling.
Could I ask you?
Yeah.
Play the scenario with MarkLogic, with how you had your cars and you started with a very small one, and then your manager said, "I want a bigger one." I mean, you used the term that you use natural structure,
Right.
and I agree with that, but it's not automatic, right? So sort of explain to me how the natural structure would have flowed nicely and given you less trouble in the scenario with the cars.
So initially,
Does that make sense?
yeah, it makes perfect sense. So the question is, how does the car example I gave work for a more natural structure if we model this as documents originally? And the answer to that is simply that if the boss said that we need different data in our database, whoever was writing the data could have just ingested that data, and the application could have been changed, and we wouldn't have had to worry about the schema update. We don't have to think about modeling data as it comes in. We just take the data as it comes in, and then we begin writing application code on top of that to take advantage of it. So we're skipping a step within the actual modeling process that relational schema modeling forces on us. So we can take data as it is. If new fields are added, we can take it as it is and just keep it in the structure that it is without having to worry about modeling the new schema to fit that structure. Does that make sense?
It does. I just wonder how you're going to get. How do you determine the hierarchy that you use? Right? Because you're talking about JSON or XML or whatever, which or for a book or for the car example or whatever. It seems to me that somewhere you have to decide this is the structure for the hierarchy. Or am I?
Yeah, no, that makes perfect sense. And my response to that is that it is hierarchical by nature. So if you think about it, we have like a core at the top, like a core element at the top. And we have like an element for the make, an element for the model, an element for the year,
Right.
and then an element for the manufacturer. Now maybe the manufacturer we want more information on. So that manufacturer element contains not only the name of the manufacturer, but where the manufacturer is located, how long they've been in business, things like that. With a relational model, you're going to have to add another table for that information. You're going to be modifying sort of the structure that the data comes in with. But with a document model, we're really just keeping the structure that's already in, and not having to worry about that complexity of modeling more tables and modeling a more complex schema as data comes into the
So you're
database.
storing it as XML, or you're storing it as JSON?
Yeah, we store it as XML or JSON. So there, if you have data in CSV naturally, there's a transformation process that needs to go through to become XML or JSON. But even that kind of information by itself can be hierarchical naturally. Whereas taking multiple CSV files and doing like VLOOKUPs on IDs and things like that, that's not easy or natural necessarily. It's tough.
But even in that hierarchy, you have to adjust the schema of the XML or the JSON, right? Because you're adding nodes.
Right, so you can't have a schema with an XML or JSON if you want to, and you can choose to enforce that if you want to. But if you're trying to keep your data model flexible and you're trying to just take data as it is, you don't necessarily have to do that. But if you think it could cause problems in your application code, if you think that it could cause errors that your application programmers didn't predict, then absolutely enforcing a schema could be the right choice for you. The terminology I used was schema agnostic, so we can work with any schema. If you choose to enforce it or not, is your decision.
It's still a schema, but a more flexible schema. XML is still a schema.
Right.
Of course, it's not like a table schema,
Right.
but it's less rigid. I
You
don't
can-
think there's
you can change
any
it
schema.
anytime.
It's
Yeah,
not-
but you still have a structure.
Yeah.
It's
You
not
still
like
have
a row and a
structure.
column
Yeah.
kind of format.
It's
I don't
not
think.
static. It's not a static
Yeah, it's not a
schema.
static
It's more
schema.
like a dynamic schema that you can mess with throughout your life cycle.
It's a
Very-
dynamic schema.
It's not really a schema, it's just what you put into JSON.
To the extent that there's a schema,
Yes.
the person that's inputting the data has to enforce it. So in the case of this thing with the security in the cars, there'd be a web page, when a new employee came in and said, what's your car? Oh, you got 2 cars. Click the add car button, and that would put another branch on that node. So at the point of input, you have whatever rules you do on that input system, and then at the point of query, you got to know what you're doing too. You got to know that there is a thing called car, because you're going to go and ask for it, and you got to know it's there. So at the very end points, you kind of have to know what you're doing.
Exactly.
Everything else is wild, wild west.
Exactly.
Sometimes it's the reverse of what it is, right? It's the RDBMS is schema on right, but noSQL is schema on right. It's the other way around, but it's not the same way that he explained. It's the reverse of what you said.
Was that the
So
question?
when you have to write the data in it, right, just in this example, when you have to add something to the existing model, you don't need to know what that schema is to fit the data in. That's the whole point of it. You can fit it whatever it is. But when you read it back, when you consume the data from your store, that's when you would come in to say, what's my schema? That's my object relation model. Right? So when you really store something, you don't need to know about your schema. You can throw it what it is.
Sure, and yeah, and that's absolutely true. That's a great point. So the point was that, when you're actually querying the data, you know the element names are and things like that to be able to pull them back. That's absolutely true. Just like in SQL, when you're querying from tables, you need to know what the names of the tables are. And just like in SQL, where you can do like select star to pull back all of an element or all of a table, you can do that in noSQL as well. Essentially, just give me the whole element back and just let me see what's in there, and give me some ways to drill down and explore it. So if we put new data in that hadn't followed the format that the previous format had followed, we could still make it go into the database, but we'd have to expand the application code and expand the queries to read it to incorporate that. But that's just a natural part of developing. Yes?
So you mentioned that MarkLogic is a NoSQL platform.
Correct.
So would you say that your competitors would be Cloudera or MongoDB or those NoSQL databases?
So I'm trying to give this talk from kind of more of an academic philosophical point of view, so I'm trying not to name any competitors by name, but absolutely anyone else in the NoSQL space could encroach on our territory in different respects. I would say Mongo is the most similar NoSQL database to us, because Mongo stores things natively in JSON, whereas other platforms like Cassandra, which are Y-column stores, or Amazon Dynamo, and features like that that have a fundamentally different data model underneath. They are in the NoSQL space, but because the data model is different, something that those are really, really, really well suited for aren't necessarily what we're really, really well suited for. So when you're looking at data models, you're thinking about what kind of model do I want to store my data in. You need to kind of ask those questions to yourself. Is my data more like a hierarchy, or is it more like a key value store? Things like that.
Could you address whether you're transactional?
Yeah, so our transactional consistency is that we're ACID compliant. So that means that we're going to have a consistent state across all points of entry within the database at all times. So if you query it from America or you query it from Japan at 2 in the morning, you're going to get the same response in both places. The database is never in an inconsistent state anywhere in the database. Another property of ACID compliance is that if any of the nodes in the cluster fail, or if any part of the database fails, you're not going to have to worry about losing any of your data. So we're fully ACID compliant.
HDFS is not considered transactional. It's like write once, read all you want. How do you compare that with your MarkLogic?
I have a more technical deck with me that actually goes into some of that information, and I can try and find the slide. If we could come back at the end, that would be best for me. I don't know the answer offhand,
Okay.
but that's a great question.
Do you do node, block replication like HDFS? Or how do you keep multiple copies across different nodes?
I'm not sure specifically how the replication works, but I think I do have a couple of slides on it also in my technical deck. But my basic understanding is that we are actually replicating the data and keeping multiple copies of it, so that if disaster occurs and disaster strikes, you haven't lost any of your data. It's still there in some form or another. And by the way, I'm certainly happy, in case there is a question I can't answer, or if I don't have my technical deck, I'm certainly happy to get an engineer to talk to anyone too who can answer those types of questions. Yeah.
So you have hierarchies. How do you differ from graph databases?
Great question. And this is the topic of my next part, semantic modeling. This is actually what I'm really excited to talk about, because we do actually incorporate elements of graph databases within our data model. So I will jump into that. Right now, there are no more questions. Okay. So semantic modeling, I'm going to totally pivot from document modeling and modeling hierarchies to thinking about something much smaller than just a document. In particular, I want to think about one piece of data, and this is a piece of data that we call a triple. Has anyone heard of triples before? Okay, great, one person. So this is actually great for me because I'm really excited to introduce you to this because semantic modeling and triples were completely new to me when I first came to MarkLogic, and it's really been one of the key pivots that's changed how I look at data. So a triple essentially has three parts. Can I use the board?
Yes.
Okay, great. So, raise me.
To your right. Thanks, Chair.
Thanks. I have a good slide on triples, but it's got a little too much eye candy in there, so I'll just draw it out quick. So a triple has three parts, and essentially it's a subject, it's two nodes on a discrete graph of one edge, essentially, is the more mathematical definition of a triple. But a triple is essentially a subject, a predicate connecting the two nodes, and an object. And this object node could also become the subject of another triple if we had it here. So subject or object or subject. So if we look at just the basic unit, the triple, and we look at the subject, the predicate, and the object, we're essentially modeling one small piece of a graph. If we model other triples to build out that graph, we've essentially built out a whole graph. So there's a common serialization out there for modeling triples, and that's called RDF, that's called Resource Description Framework. And I'll give you an example of RDF in just a second. But the basic idea is that you can model out complex graphs using triples, and doing so gives you traversal capabilities that you otherwise wouldn't have. So semantics is a new way to organize data. So data is expressed as triples, as a subject, a predicate, and an object. And here's a couple of examples. Yep.
I had a question. Can you give a good, for these guys that don't know it, can you give them a good explanation of where it comes from, where the whole concept of semantic data comes from?
Yes. So I'm going to skip ahead a couple of slides to do that.
Just the concept of it is really critical to really understanding why it's a very key thing for the future.
Right. So why are triples important and where do triples come from? So triples are essentially facts, right? So three parts. So John lives in England, and maybe we have another triple that says England is in London. We put the two triples together, England is a joining node. Now we know that John lives in England because we know that London is in England. So where do triples and where do these facts come from? So these facts come from all over the world. So there's linked open data sets out there like DBP and GeoNames, which will give you some triples and give you some of these facts. DBP in particular is a really interesting data set. It has facts like Einstein was born in Germany. Einstein is the subject, was born as the predicate, and Germany is the object. Ireland's currency is the euro. Ireland is the subject, currency is the object, and the euro is the predicate. And in the GeoNames database, Doha is the capital of Qatar. Really, really interesting facts and really, really interesting nodes that you can join on to get very complex questions answered with these facts. You also get facts from within your own business and within your own domain. You may have open data about your hierarchical structure, like who works under a manager or who works under the CEO. You may have facts about your industry.
Can I step way back even higher than that?
Okay.
If I talk for just a second?
Sure.
The whole concept of semantic web, if you step way, way back and go to the origination of it, is if you look at the web today, what is it? A bunch of documents, a bunch of Word documents linked by saying you click here, you get a new document. You click here, you get a new web page, wiki, whatever. But it's very, very, very difficult for a computer to understand what's going on. The whole concept of the semantic web is to model the data such that a computer can help you understand what's going on. So you put these links in there. The difference between a semantic link, you can think of that as a link, and a document link. It's just a document link saying, go there, there it is. A semantic link gives you context of that. Like you said, John lives in London. Well, you put a bunch of those together, the computer can analyze that and build you John, and it'll find all the links. It's your social graph. It's your method of being able to analyze through a computer rather than a human what the connections are. Is that fair?
That is absolutely correct. And we also like to use the word inference a lot when we're talking about making assumptions about data that we don't know yet, by being able to make these disjoint connections fit together and
Yeah, and I've
traverse the
forgotten,
data.
step way back, I've forgotten the guy's name. Who invented the web? I lost the name, I can't believe it. But Berners-Lee, Tim Berners-Lee basically said that's his concept. He moved out on semantic web. He's one of the first guys that started. And that's where the world's got to go. That's what the model of the web's got to go for computers to really help us. I mean, we're the computers today. Thanks a lot. Read the document, click here. Great. But you can start really using that information. Computers can start using that once you get to semantic.
Right, absolutely.
So does MarkLogic, as soon as the data gets put in, does MarkLogic essentially build the interweb connected model?
So MarkLogic won't build the triples for you, but MarkLogic will take the triples that you've put in the database that already exist, and they'll put the connections between them so that you can traverse it.
So the connections, the infrastructure between all the data points on the graph. I'm a math nerd, so that's where I come from. So the edges in the graph is where
Exactly.
MarkLogic comes in.
Right.
The
Yeah,
edges-
I'm a math nerd too. Like I can talk about Eulerian cycles and all that fun stuff if you want to. But yeah, I love graph theory so much. It's one of the things that really drew me and convinced me to work here.
Yeah, it's a long time coming. Semantic web's a long time coming, but it is incredibly powerful if you really start looking at it. There's a fair amount of information out there, a fair amount of documents and books you can pick up. I'm sorry, I'm just very passionate about this. This is a strong future thing.
Yeah, right. So even the Neo4j is implementing the same thing.
Right.
That's okay, right?
Yeah, so I'm,
In the memory.
I thought that already.
So
They already have this.
Oh.
See, I'm not a mathematician, but one of the mutations which I like is, I don't know if you guys are using hierarchical manager relationship. Try to build hierarchies all the way from the geography to a business unit to all the way to an employee and try to connect it to the traditional RDBMS. It simply sucks you out. And even you lose. Writing the queries are so complex.
Right.
absolutely.
So this actually helps in a way.
And this is one of the few products, enterprise products.
So we're the only people that can really do it at scale, essentially. And I know that sounds like a big claim, but I challenge you to challenge it. We are really the only people who can do billions and billions and billions of triples.
So does the MarkLogic product understand, like, John lives in London, London's in England, England is in Europe. Does the product understand that if I want to know what continent John is in, it will give me Europe very quickly?
Yes, absolutely. So you need three things to do this. You need your facts, which are your triples. Then your facts have to be indexed, so they need to be stored in the database, and the database needs to be put those connections together. And then you need a third thing, and that's your query language to actually ask that question. So let me actually jump backwards in the slides now.
That's the question.
This is actually
This is
the
exciting.
yeah, this is great. So this is actually the default order that we give these slides in. But when I was looking at this on the plane, I was thinking, maybe I should change it a little bit. Should have gone with my gut feeling. Okay, so here's actually the three things you need. So here are your facts, and facts are usually serialized in RDF. There's various formats of RDF out there, like OWL and Turtle and things like that. I believe these are Turtle. So we see John lives in London, Stephen lives in Southshire, Southshire is in England, London is in England. Basic triples, they all end with a period, because it's just essentially insinuating where the triple ends. But then you need a query language to actually ask that question. So, this is a query language. So there's a query language out there called Sparkle, and it's essentially one of two query languages that I really use to answer these types of questions. Many people say Sparkle is the only query language essentially for this kind of semantic data. And this is what a Sparkle query looks like. If we wanted to say, what country do my people live in? So at the top we've got two variables. So we want to know the person and we want to know the place. And then we want to say, find me any person who lives in any place, and then find me any place that's connected to England. So when we look at just that small subset of the graph, we're saying, we're essentially saying, just return me the person, the place, but make sure that person is anyone who lives in any place, and make sure that place is any place that happens to end in England. So, we would get back two columns in this kind of a query, and it would say John London and Stephen Southshire, because we know that both of those are in England based on the triples and the facts represented here. So Sparkle is a query language. It looks kind of like SQL a little bit, but it's much simpler to use. You have to obviously understand your data, and you have to understand your triples to be able to pull out the predicates, subjects, and objects that you need to construct these queries. But it's really, really useful and really powerful to traverse billions of facts like this.
Yeah, I want to throw one other thing in. So
Please do.
I can't remember the name of the open semantic web thing, but basically people have been throwing in RDF triples in just piles of data and exposing them through HTTP or whatever, I forgot what it is. And then once they expose it to a top level way, you can combine it all into a huge graph that are completely separate piles of data that now you can traverse through and figure out different information from them. With data you never put in, somebody else has.
Right, that's the DBpedia project, I believe.
What was that?
DBpedia, I believe that's the website that has all the information. And people go through the data too, and they validate it, and they make sure that's actually good, and there's discussions just like with Wikipedia about whether a fact should be kept or not, and things like that.
Yeah, it's a way to tie all this stuff together. It's really powerful.
This type of traversal is very fascinating.
You mentioned indexing. You don't have to index it, but you need to index it for performance.
Exactly.
I mean, it's your standard problem. You can traverse anything non-indexed. It'll just take 100 times as long.
Right. Please go ahead.
This is my first time hearing about semantics. So, what exactly, like the specifics of what is it that, why is it like so challenging? What are the difficulties of it, the semantics that, like the missing links or something?
Yeah, so this almost kind of goes back to the hierarchy problem in the sense that semantics are natural, right? So it's really hard to represent them in like rows and columns and tables. And if you do, you're doing lots and lots and lots of joins across different tables, and that's usually not performant. But if you start with a data model that actually looks at triples and is built to support triples, then you're actually going to get performance out of that, and you're going to be able to run that type of query very easily.
So can triples be used for really long hierarchical structures? So for example, in manufacturing, you have an assembly, and that assembly could be made out of boards, and boards have chips and blah, blah, blah. So we call that the bomb explosion.
I'm going to skip really far ahead to one of our use cases, because I'm skipping really, really far ahead. So we have a company called Mitchell One that we work with, and that is exactly what they do. So Mitchell One is a knowledge graph for car parts. So if you have a question about a car, like, what is the problem with this muffler, things like that, Mitchell One will go through their graph database and they'll say, okay, this is the problem you have. This muffler has this problem and it's documented, and this problem links to this report describing how to fix the problem. And Mitchell One gives their database to a bunch of actual mechanics out there working in the field, and they're able to query the Mitchell One database and find information like that. So the Mitchell One CEO was recently at our MarkLogic World event, and he said, this is what we're trying to do with Mitchell One. I was listening to the radio, and I was listening to Car Talk on NPR, and someone called in, and someone said, I have a problem with an engine, I'm driving it forward, and Car Talk guy cut him off. And he said, your problem is the gasket. And he was like, well, I didn't even tell you what the problem was. And he said, you're driving it forward, you said you live in Michigan, it's winter, it's cold, all these gaskets are blowing. And it was just incredible that the Car Talk guy knew that immediately because he knew all these facts about the car and the model and things like that. And that's what Mitchell One is trying to do with their graph of knowledge. If you give them just a few facts, they're going to tell you exactly what the problem is without even you having to do the research or you having to diagnose it, look for it on your own.
And the key is where you were asking about, you're not developing a whole schema around this. You're just collecting facts and throwing them into a big pile.
So this triples concept, is it the same in Neo4j too?
Yeah, it's essentially the same.
Actually, Neo4j also, basically all of these evolved from Spark. So the triples, they're called as RDFs. So they were all primitive, but Neo4j was more modern. I think MarkLogic, I don't know, it seems like on contemporary.
So how is it compared to Neo4j, MarkLogic?
So I know that marketing is going to be watching this recording. And I know that there's also another product I like out there that's a triple store tool called Stardog, which I'll mention. But basically, Stardog and Neo4j can't reach the scale that MarkLogic will. They're not going to get the performance. They also don't have the enterprise features that we have. So they don't have security, they don't have ACID transactions, things like that. So if you're going to be using this type of data, it's great for research, but don't use it at scale necessarily.
So,
And you may have problems with an enterprise integration. We've replaced a lot of Neo4j installs.
I don't mean to jump ahead, so are you gonna show how you build those relationships, like the predicates in your product, or no?
I could, actually. I was trying to put time at the end. I do have a semantic demo that I put together that I was going to give at the end. Yeah, okay. But he was going to let me know when I hit 30 minutes. So if I hit 30 minutes and I haven't gotten through all the material, I'll make sure I jump to that demo.
So
Yes.
in this example that you gave, in order to build this hierarchies, you had a transactional system where you siphoned off the data from your transactional systems to your MarkLogic noSQL database, and then you build your analytics or reporting.
Yeah, so if you're building your own triples, that's the way you would do it. But people have been serializing triples in like RDF for a long time. So if you have triples that are ready to go in RDF, we'll take them as is and we'll do all that transformation for you.
So if you have a relational data model that is built in some kind of like modeling tool like Embarcadero, and you have the predicates as best as I can describe it, right? Because between two entities, you can say
the join is the predicate.
The join is the predicate, and sometimes you define, lives in or works for or whatever. Could MarkLogic integrate and sucks those relationship from an external modeling tool?
Yeah, hypothetically. So we have like ODBC connectors, we have a Java API, we have a tool called MLSAN, which pulls some data from Oracle and relational systems really well, really quickly. And if we understood what information was coming in and we wrote just a little bit of logic, I'm sure we could build those triples on the fly for you as they came in. So I'm going to limit questions to 2 more so I can get through the material. I don't know if that's a good thing or a bad thing. If I hear a lot of boos, I might have to back off, Brad. I'm sorry. But I'm going to try and limit it to 2 more because there's a really big connection I want to make between documents and triples. I have to get back.
You make sure you cover integrity. It seems to me one
Yes.
false fact will ruin your entire data set and anything you do with it.
Right, absolutely. So there's this new class of people.
You don't have to answer now, I'm just saying, that's what's going off in my mind. This is great, but
Yeah.
how do I know I can use it?
So imagine this. Imagine that you have a triple connected to a triple, and the triple says, this triple may be false. Imagine that. So when you get the answer back with the triple, you're going to know, based on that triple, that, hey, there's a chance this triple might not be true, maybe you shouldn't trust it. One of our ontologists, one of our data scientists said, double check this triple.
But it's the same problem with the data integrity. We're not doing a sampling. If we are pulling out the entire bomb or whatever, let's say we connect to our RDBMS, we pull out everything and convert it to triples, it's not one data set, it's the entire data set that's going to blow out if the integrity is not proper.
If I say Texas isn't England,
Yeah.
Right.
then whatever you do that follows that traverses that path is guaranteed to be wrong.
Right,
But
absolutely.
you would never know because that's going to be a middle piece, and you're looking at what came out at the end.
Right. So obviously data quality is an industry in and of its own and has, people who try and solve these kinds of things. There's companies out there that do algorithms for this. So we've done some data quality scenarios with like queries, and you can put like tasks on MarkLogic if you have an algorithm that can detect these anomalies and go through and clean up their data. But yeah, it's a big problem, and there absolutely needs to be a solution for it that you need to be thinking about as soon as possible. I know there's some people in here that had like career questions and things like that. If you're interested in semantic data and you're interested in only looking at like modeling design semantic data, there's a whole field out there called ontology, called ontologists. Ontologists are people who essentially describe taxonomies for enterprises and have triples built off of it and go through data and make sure that data is qualitative. So it's an interesting field. One more.
The SQL that you wrote, what do you call that?
So that's Sparkle. That's not SQL. That's Sparkle. Yeah, so that's a query language in and of itself designed specifically to query triples.
Okay.
And MarkLogic supports Sparkle 1.1, which is the latest W3C recommended version of Sparkle.
So if I write the Sparkle, right, the execution engine can be anything. It could be run on MarkLogic. It can run on other databases. It will be the same.
Yep, same Sparkle. Because your predicate, subjects, and objects should be the same. Okay, so I got a little sidetracked in my presentation, so I'm going to try and, let me just sift through. I'm just kind of trying to remember where I was, or where I should go actually. 1 second. Okay, so I think we covered where triples come from pretty well. The one slide I really just want to focus on was this graph slide, because we see this in enterprises a lot. You have a fact, maybe an employee works at this institution, maybe this employee studies that subject is a type of this category. I just really want to show that graph and just focus on kind of the complexity and the variety of different facts you can have. I do think we covered that pretty well in some of the discussion too, but I just want to make sure you see that graphic before I continue. Because this is where things get magic. So I'm going to jump ahead again. So we know that facts, okay. So if we talk about facts, we talk about how you can get facts from the world at large. There's linked open data sets out there. You can develop your own. You can get facts from within your own business domain, facts about how your business works, facts about who works under who, things like that. But you can also get facts from documents. So this is pretty cool. So we have a hierarchy up here. That's a document hierarchy. And what if we put a triple in that hierarchy? What if we say this author wrote this book, which is a triple, and we put it right in the hierarchy? Well, all of a sudden we have a connection between the document and the hierarchy. So you can say, show me all the books written by this author, and then actually view the documents that come back with the book, not just the notes. And that's pretty magic when you can do that kind of stuff. And you can actually see data and not just know about data, but actually see it and actually see what's coming back. And this graphic up here on the upper right kind of shows that relationship. So we have a triple on the upper right of the graph. And you may remember from the suspicious activity report I showed earlier that there was a triple in the upper right of the graph. And once that triple is in the document, you're connected to the graph at large. So if you want to make a Sparkle query and you want to, at the end of it, say, show me the document that contains this triple, you can do it. You can have multiple triples within your document. If you didn't develop your data model to initially support triples, they just work out of the box, put them in there. If you want to add more triples to your data after it's in there, not a problem either. That's what comes from having a more flexible, natural, hierarchically structured data model in place. I'll pause one more time for questions, since that was the big point I wanted to get to.
So is this picture you're just putting it together for the presentation, or does MarkLogic as a tool that brings out this particular relationship and it shows it up to you in your tool?
Yeah, absolutely. So you can combine queries to actually get this information out. So if you
the pictorial view.
He's saying it does your tool.
Oh, we don't have a visualization component like that built into the tool. However, I've actually developed them for clients using D3.js, and there's another JavaScript library I really like called Viz.js. So as long as you write a query that just returns the JSON format that these libraries expect, it's very simple to visualize them. I think we have some examples out there on GitHub that I'd be able to find for you too. Yeah.
So is the point of this image that you have two different types of data sets? One is a hierarchical and one is a graph format, and you can join these two through MarkLogic? Is that what you should?
Essentially, but even more so than that, the actual node on the graph itself is a document. So that subject is a document, that object is a document. So we have a graph of documents essentially interconnected together once we combine documents and graphs together. And no one else does this except us.
So if you have a document repository,
Yeah.
like SharePoint,
Okay.
and you want to extract, would this be a good application to pull some metadata as well as some of the documents itself out of SharePoint?
So we work with a partner called MarkLogic for situations like this. So MarkLogic is a tool that helps you manage your triples and ontologies. And MarkLogic has a tool built in for SharePoint, and MarkLogic will take your SharePoint document and enrich them with triples. Once you've done that with MarkLogic, we have a connector from MarkLogic to SharePoint, and we will pull back the triple-enriched documents from SharePoint, and we will ingest them into MarkLogic, store them as they are. We have pipelines to convert MS Office formats and PDFs into XML structures and things like that, and you can query them basically immediately.
So you can make the document searchable.
Exactly.
Wow.
And the documents become text-based searchable too and things like that, so you can Google on your documents and they become part of the graph.
Beautiful.
Yeah, but not just text-based searchable, these cross-link searchable.
Yeah.
It's searchable is available already.
Yes.
And I'll talk more about use cases later, but that exact use case was something I did at Monsanto while I was there. I was actually one of the first people in the company to do this, so. Okay.
By the way, Sparkle is spelled S-P-A-R-Q-L.
Yeah, so Sparkle itself, I can't remember the full name, but the S actually stands for Sparkle. It's a recursive name in and of itself. Kind of funny, I guess. Traversal joke.
Yeah.
So just like we can get facts about our documents, we can also get facts about our data. So things like when was the data inserted, where was the data inserted, who inserted the data. This document was inserted by John, this document was inserted in England, things like that. So not only are we able to connect to this graph of triples linked together by the content of the data, we can connect this graph of triples linked to about the data itself and the metadata about the data. So any kind of connection that you can envision going into this big graph, it can be done. So it's really cool.
Can you put a reliability score on the person that's inputting the data?
Sure, absolutely. So you
So
could
that gives you some intuition about the connections being made off that.
The quality of the
absolutely, yeah, absolutely. So if you said John inserted this document that was a triple, and then you had John is not reliable or John is reliable, you could say show me only documents inserted by reliable people or something like that. Now you might have to change that triple down the line if John graduates from being an intern to a full-time employee or he becomes better at his job, but yeah, absolutely. And by the way, I didn't put a slide about this in my presentation, but there's also a feature in MarkLogic called bitemporality. So bitemporality is basically the idea of seeing what changed between your data. So it's a query that you can run to say what values changed in my data. So if you say that John is not reliable, and then John becomes reliable, you can say, show me only data that was put in by people who used to be not reliable but now are reliable, or show me only the data that was put in by John when he was reliable instead of when he was not reliable. So you can take advantage of that bitemporality capability of the database to actually answer questions like that. The only reason I didn't put a more detailed slide about bitemporality into this presentation is because I thought I'd have too much material to cover. But if that's something you want to talk about more and look at that feature more, I'm happy to open up my technical deck that has the master slides of everything and go through that feature more. Okay, everyone's mind looks sufficiently blown. This is good. This is exactly the talk I came here to give. Okay, the nerves have gone away. Okay, so you essentially need three things for triples. You need somewhere to store the triples. If you want performance, you need a triple index, and you need a query language. And Sparkle really is the industry standard for doing querying. You will find some other data out there on the web that can be tripled in different formats or queried in different formats, but really RDF, Sparkle, and a triple store like MarkLogic is really essentially the industry standard today, as I see it. So this is kind of our architecture slide and semantics. This is really technical, so I'm not going to get too into the weeds. But in your interface, you have all your documents, your query language. But actually, this is just a MarkLogic architecture in general. So your interface layer, you have all of your documents, you have your tools that work with the database. At your query layer, MarkLogic will let you query the database in JavaScript, XQuery, SQL, or Sparkle. If you're doing triple queries, and you may be embedding Sparkle within JavaScript or XQuery or something like that. At the index layer, MarkLogic indexes everything to make it searchable, and we'll go through text-based search and search capabilities of the product in just a moment. And then the storage layer, that's where a lot of your enterprise features come in. Your enterprise grade scalability and elasticity, ACID contractions, automated failover, disaster recovery and high availability, things like that you can trust. So let's talk about search and query. So now you've got all these documents in your database, you've got triples in your database. What can you, yes?
30 minutes.
Thank you. Okay, so I'll go through search and query really quick. I'll go through application services really quick, and then hopefully I can do a demo. Kind of not so quick, so we can just look at something cool. Okay, so search and query. So MarkLogic indexes everything. So when you put a hierarchically structured document in your database, it's going to index every word in that document, and you're going to be able to do text-based search on your documents out of the box. I could give a demo of just how quick that goes if you really want to see it. It's dirt simple. Takes 2 seconds. So that's sort of the universal index. That's just everything MarkLogic indexes by default. So you could do things like which suspicious activity report contains the phrase blue bank. When you see, okay, here's how the indexing works. It's essentially a hash map that pulls back these documents, that pulls back the actual documents from those reference IDs. Pretty standard chain hash indexing. So then we have range indexes. So these are indexes that you set yourself. So these might be like, put a range index on this date value. So then that way I can query against, this date value. I can say only show me documents that have this date element and have a date between these two dates and things like that. Then we have geospatial indexing. So we will index latitude and longitude coordinates pairs if you turn them on. So we can answer questions like, show me anything within 5 miles of Houston. Show me anything within this polygon that I've constructed that may have 7 or 8 points on it. And then of course we have the triple index. So we can enhance our queries with triples and actually see, where they fall in the graph and what triples or which documents may be related to another document with triples. And all of this can be combined together. So you can do a query that has geospatial properties, range index properties, universal index text search properties, triple index properties, and you can find the exact specific document that you're looking for. Or it's just a great discovery tool. Maybe you don't know what you're looking for, but you know you're looking for something within a general area. Once you kind of drill down on that area, you can keep drilling into it further with more complex queries until you find what you're looking for. So you're going to find whatever you want, whatever you're searching for pretty quickly. So now, the database is cool, the query language is cool, the data analytics is cool, but you want to build an application off that your boss can use, and he can click one button and he gets his data back, or he can play with a field or play with a map, something visual, and actually query data that way. So how do you build your application on top of MarkLogic? I couldn't find the slide for this, so I wrote one, and I apologize for the whole text. But basically, you're going to use XQuery, JavaScript, SQL, and Sparkle to query the database. Those are your query languages. To connect it to your application code, you're going to use REST, our Java API, or our Node.js API. For those of you who are Python fans in the audience, we do have a Python API that we put on open source now. A lot of people in the company are working on it. It's not quote-unquote officially supported yet, but it works really well. We have ODBC connectivity, so if you have a BI tool like Cognos or Tableau or Spotfire, you can connect through ODBC or REST, of course, if you wanted to. So Hadoop HDFS, I know there's a lot of buzz in here about it. I'm going to have to gloss over it because I just don't have the time. But if you want to use HDFS as your file system for MarkLogic, MarkLogic has to store its data somewhere. You can store your data on HDFS if you want to, and then you can take all the data that MarkLogic store and you can run Hadoop-based MapReduce jobs across it. So you don't have to, it's not a choice between MarkLogic or Hadoop. The two can play together very nicely. And we do work with Hortonworks from time to time too to integrate this for enterprise customers. So if you're working with a language that doesn't have an official API, although Python has one that's really, really good. So if you're working with something like R, you can easily pull data out of MarkLogic with your language of choice, whether it be REST or ODBC. Or of course, you could just dump the data from MarkLogic and then run analytics on it that way. You could write a query to pull data out, save it to the file system, and then run your R query that way. If you're looking at ingesting data from like a Microsoft Office file or PDF or other types of data, you can pretty easily pull that data into MarkLogic, and we'll do some conversion for you and make it easier. You might want to do some conversion on top of it if you don't like our default format, but our default format's pretty darn good. So real-time analytics, a lot of people are really excited about real-time analytics. I want to get an analytic out really quickly, and I want to do it as data coming in the database. That's really where indexing provides. So you can search based on facets in your data. You can aggregate data together. You can look at co-occurrences in data, which is another feature I didn't cover. But basically, you can say, what's the most common pair of two objects in my document. So maybe if you're storing documents that have like products in them, and you're storing like a list of things that people bought, you can say what are the two most common products that people buy together. We actually did this analysis based on Twitter data, so we did like what are the two most common products that we see in tweets together. And for example, we found Pepsi and Tylenol, for example. So people seem to buy Pepsi when they're going to Tylenol because they have a headache. So co-occurrence is another type of querying that you can do. That's just really cool. There's so many features baked into the product, I can't go through them all. I wish I could. If you want to give me another hour and a half, you can share. You're able to let me stay. And you can combine all this together. We talked about Hadoop, and I'm just going to essentially skip that. But yeah, they will play nicely together if you want to not sacrifice one or the other if you don't have to. So let's talk about some use cases quickly. So Monsanto, I said I've been in Monsanto for about the past 8 months. Working there. I'm going to be very careful with my choice of words and respectful to NDAs. But essentially, Monsanto has built out a lot of facts about their domain inside their business, and these are facts about the genetic research they're doing. These are facts about the products that they have and where they're located. They also have information about their fields and crops and things like that. For those of you who might not be familiar, Monsanto is essentially an agricultural company that develops different types of seeds and grows and ships them to farmers to be grown. So you can combine all this data together, and you can say, what are all the fields that this gene is stored in, or that this gene is used in. Or, if you're not looking for a particular gene and you're looking for a trait, genes are connected to traits via triples. You can get the same set of data back just by searching for all the traits that are affected within a particular seed. We do a lot more use cases at Monsanto rather than that. Our company motto is kind of land and expand. So we start with one use case, and then once they see how useful we are, we just grow into many, many more use cases. Just like I kept getting many questions, I'm sure I'll have many more. Use cases grow out that way too, and we really tend to expand across large enterprises.
Good question.
Sure.
Why, I mean, obviously, couldn't they move that whole different data to Hadoop and run analytics on that to find, all the use cases you mentioned? What was the need to have a noSQL or MarkLogic noSQL in that scenario?
The triples essentially was the biggest driver that brought us in, but I don't know if I can say this or not, but I'm not going to say they didn't try it before we came in too. That's all I feel comfortable saying.
I hate to stop you, but
No, go ahead.
For my interest, could you elaborate just a little bit or very briefly on, you said you can ingest the Cognos data.
Oh yeah, so we will connect with Cognos. We have.
Are you saying about Cognos Powerplay cubes, or what are you talking about there?
So that's a great question. I can refer you to someone in our engineering department who can probably answer that. I know that we connect to Cognos via REST or ODBC. I'm not sure the specifics on the data transactions between the two systems, but I do know that we're working with a really large healthcare provider right now to implement Cognos there. And so far, I really haven't heard of anything detrimental or anything that couldn't be done so far. So we even have some documentation on our website about connecting MarkLogic to Cognos that you could look at that may be useful. So here's my favorite use case. How many of you have seen NBC's new Saturday Night Live app? So Saturday Night Live, for their 40th anniversary, released an app that will let you view any video within their 40 years of TV.
Awesome.
So thank you. I didn't work on it, unfortunately. I wish I did, because this is such a cool product. But the app looks at what clips you're watching, it looks at which segments you're watching, and MarkLogic powers a recommendation engine based on the metadata and based on the triples to help you find the clip that you probably want to watch next. So if you like a particular character in an SNL skit, or you like a particular actor, the app is going to figure that out, the app is going to generate queries, and the app is going to pull back the clip that you probably want to watch next. I can't really speak to the usage metrics or usage statistics, but suffice to say, this is another example of where we perform really well under a large scale. The reviews for the app have been phenomenal. Go to the App Store and check it out. It's a really cool application, and it's all powered by triple semantics.
Is it running MarkLogic also in the background?
No, so the app itself does not run MarkLogic. MarkLogic's run on a server essentially, and it's querying the server.
Oh, but the app is using it in the background.
Yeah. The app is leveraging systems built with MarkLogic.
So internally, does it bring a job or something to when the query is fired, or is it just there is no job itself to execute?
Yeah,
That was the node.
Yeah, there has to be a job on the server to figure out the recommendation that's done. I don't have time to talk about how we scale out and how we do evaluator nodes versus data nodes and server architecture like that. But if you want to touch base with me anytime after the talk, I'm happy to try and cover that in more detail. So BBC, we did the 2012 Olympics coverage for the BBC. This was, again, powered by semantics and document metadata, so we were able to figure out which articles you probably want to see when you're on the BBC homepage that would be most interesting and most useful to you. Great example of triples and semantics. Disney, so this is a new one that we can finally talk about. So the way that I've heard it phrased, which I believe I can reuse, is that Disney essentially had questions about their domain. They wanted to know, do we have an Italian version of Snow White that was published before the 90s or things like that? Or actually they want to know, do we have an Italian translation of Snow White, the original version, and who was the author of that translation originally? And it sounds like a simple question, but it's not, because they don't have this data organized. So they've had people going together, putting together facts and data within their domain, and they've brought all this together with triples. We've expanded to a lot of really interesting use cases of Disney, which I don't really think I can talk about. But suffice to say, we're doing really cool things there, just like we are with Monsanto. So there's an energy trader, or there's a company that trades energy products. And what they do is they look at IMs and emails and things like that, and they pull the text out of it, they build triples based on the text, and they're able to say, okay, well this trade looks suspicious, or this looks like it might be a piece of fraud within our company. And then they can say, show me all the trades that are connected to something suspicious on the graph or things like that. So they're really able to enhance the kind of regulatory compliance that they deal with by enriching their data with triples and using our complex querying to actually find the data they're looking for in the first place. We talked about Mitchell 1 earlier because it was very relevant to a question that came up. But essentially, Mitchell 1 puts together facts about car parts and they get given to mechanics. So if you're a mechanic and you're wondering why a part isn't working, their database can answer that for you really quickly with only a few small pieces of information. It's very impressive. So the one slide I seem to have forgotten is healthcare.gov. So we don't use any kind of semantics really that I'm aware of at healthcare.gov. But healthcare.gov is a great example of how we're taking healthcare forms that people fill out, which are documents, naturally structures, hierarchies, and we just put them in the database as they are, and we're able to operate on them, understand them, and help Americans get access to health insurance easily. So there's no consistent schema between all these different companies. Even companies themselves don't have consistent schemas between states, but MarkLogic's able to manage all that, and that's probably the biggest publicly available scaling out that I can talk about. Yes?
So in the healthcare.gov, the input is not being provided in terms of the triples. Are you creating the triples based on the documents that are being?
I don't think we're actually using any kind of triple or semantic technology in healthcare.gov that at least I'm aware of, but I can try and double check internally and get back to you if we are. The big point with healthcare.gov is that we're taking a bunch of different health insurance forms or health insurance fields from a bunch of different providers. They're not any kind of a consistent structure, but we treat them as a hierarchy. We put them in the database. We're able to read, understand, interpret them, and help people gain access to healthcare very easily at a large scale.
Because the reason why I asked that question is that it seems that the biggest advantage is that your starting point should be that you should have a triple in order to take advantage of this. So if my company, we don't have data organized in triples, then I can't really use this unless I start building the facts the way you're explaining them.
Well, we existed semantics is a relatively new feature in the database. We've been around for about 10 years before semantics was implemented, as far as I understand the history. But there's a lot of customers we have who actually don't use semantics at all. I'm working with the American Hospital Association right now. They don't use semantics. They use this as a document store to help manage the different kinds of questions that they're getting from patients and being able to respond to those accurately, because those questions don't come in any kind of consistent format. In fact, they come as PDFs, which are really hard to put into a relational system as anything other than a blob.
But I still didn't get his answer, or maybe. So if you're a new customer, what would healthcare.gov provide all the different kinds of health insurances, and then you opt either of them, and then you fill a registration form. Basically, then you're connected. Till that point, I'm not able to make a connection where would, forget semantics, where would documents also be more effective? Because that's a web page where there's more content at that point. It's showing you different kind of plans, different kind of benefits. It's pure content on the web page.
Right, but those plans don't come over in any kind of consistent format at all. We have to ingest them, we have to understand them, we have to be able to present them to customers in consistent format so that they can easily compare the plans with each other and understand which plan will be right for them.
But that you do in the traditional Java way also. You put your content and then you have your comparison plans all together. You still can do that, achieve it. So maybe I'm not getting that.
Yeah, maybe I'm not explaining the best way. Certainly nothing's impossible. I'm sure you could use any technology to solve any kind of problem. But when you're working with documents that have lots of fields and subfields, like how many children do you have? You might have 1 child or 2 child or 3 children, and things like that, and being able to interface with basically every other healthcare provider out there in the world. It's a challenge, and it works best when you're working with hierarchical data.
In general, I don't know, I'm asking the simplest question.
Yeah.
Is basically, let's say my starting point is my company documents and media, web data, everything, unstructured data. So is there you mentioned a DBA, is a publicly available triplets database?
Yeah.
Is that something can drive digesting the data and indexing into triplets, or somebody have to understand the data and build triplet definitions?
Yeah, you can go out, grab that open data, put it in MarkLogic, and then start querying it immediately. You'd have to probably look at a triple to understand where to start querying it, but we have free training courses that are available to anyone completely for free. And in our semantics training course, that's actually what you do as part of the course. You go out, you grab these open free triples, and you learn how to query them and learn how to build queries on them. I'm going to take one more question, and then I'm going to go to demos for time constraints.
So does MarkLogic is able to handle files? Are you able to store videos or pictures in the database?
Yeah, you absolutely can store binary data. We have object types to support that. And if I'm building a website or something off of MarkLogic, I do that pretty frequently. Okay. So live demos. So I have two to show. Like I said before, I'm clearly not a seasoned sales guy. I'm clearly not a seasoned speaker, but I do my best. So the two demos that I chose were really the two that I know best. One of them has never been shown publicly before, and I put it together. And the other one is the demo that we show to everyone to kind of demonstrate our performance. So I'll do this one first. This is MarkMail. So essentially what we do is we ingest tons of emails from tons of email lists, and we throw them in the database, and we have an insane amount of data in here. We have 75 million different emails. We initially started ingesting this data in November 1992. Out of all the lists we've ingested from, there's 2,682 currently active, and we gain about 21,538 messages per day. Huge amount of data in here. And we can type in a text search. We can type in a company. Maybe we're going to type in Disney, since we were just talking about Disney. And very quickly, we get all the relevant emails about Disney back. We see the first 10 of about 9,278 mentioning Disney. We see some analytics here about the messages per month mentioning Disney. We see the list that the emails came from, ordered from which list has the most mentions or which list has the least. We also see who's sending these emails, ordered from who has the most and who has the least. And we see the attachment types from the most Disney-related emails have GIFs attached. Maybe not surprising since they're an animation company. And if we want to drill into these more, we can click on one of the facets. So, okay, what were the Disney emails from the org Python list? That might be relevant to us, and there they are. And all the same information is here again, but we're just looking at a subset of that larger set of data that we started with. MarkMail is a public demo, markmail.org. I encourage you to check it out. I encourage you to explore the data, and it's a great example of how we do text-based searching. How am I doing on time?
You got about 12 minutes.
Okay, 12 minutes. So I guess I actually may have time for questions at the end. I'll try and rush through my demo pretty quickly. So with that in mind, I put this demo together over the course of about the last month, mostly working on weekends, because I was really interested, A, if I could do it, and B, I really need to learn Node.js a lot better than I knew it. So this was my excuse to learn Node.js. So I put together an application that will work with the Twitter API to take in data from Twitter and let you search it instantaneously. So it's called Twitter Surveillance. I tried to make it intentionally creepy on purpose because, this is who I am. So we'll log in. You're beautiful.
That's not you, is it?
No. My fence is white. Okay, so basically you just go to configure settings, you click here, and you put in your API keys. I've already done that, so you can just jump through the demo. So I have an ingestion screen. If you want to ingest tweets from someone's username, you type them in, and you're good to go. So I have a friend who uses Twitter, and I'm going to ingest his tweets. Twitter has an API to help you search things. So you can search like the most recent tweets, the most popular ones, a combination of both. Let's search for pizza. The Twitter API wants a location that's pretty specific. It wants a latitude-longitude pair, essentially. I just wrote a little bit of code in Node.js so that you could just enter in general locations, and it would do geoconversion to figure out what that point was. So let's see who's talking about pizza in San Francisco. And by the way, pizza is a pretty innocent thing to search for, but I have done this demo to people above me before where not so innocent things have come back. So if you see something that offends you, I apologize, and please let me know, and I'll take it off the screen. I feel like putting that disclaimer in. And we're going to search within 7 miles of San Francisco. We'll click this button, the tweets are in there instantly. You can also ingest from your own timeline if you wanted to. I don't follow anyone, I just have essentially a bot account, so there's not too much value in doing that right now. So we can just go to search, and here's all of our data that's available in the system. So I've got 196 tweets altogether, and that's because I'm really rate limiting the API to not accidentally charge myself money or get blocked by Twitter. So I'm only doing this in small batches of tweets at a time. So I've got two different types of facets on the tweets. So I've got hashtags, and I've got the usernames who tweeted them. You click on a hashtag facet and the data updates instantly. So okay, here's all the tweets talking about pizza. We can see them essentially as a table format. We can flip between the two pages quickly. Let's view them on the map. So here they are. They're all in San Francisco, which is what we asked for. I built out some visualization tools based on Google Maps. I've also worked with Esri and ArcGIS extensively before for visualization. I wanted to get that into this demo too, but I just didn't have time yet. We can turn the markers on and off. We can view this as a heat map instead if we want to. We can also do like a cluster view, so we see 20 tweets here. Click on it, 4 tweets here. You click on the marker and read the actual tweet. Twitter Day is interesting because it's semi-structured, and we're able to manage that as it comes in, whether it has location or not, and just display the information that's there. I also have this chart view that, this is the creepy part. Let's do the creepy part. So, if we go back to table and I switch down to my friend's tweets, we've narrowed it down just to his tweets. These are the hashtags he uses. He uses Astros a lot. Houston Astros, the Astros baseball team. So we'll look at just the tweets he did that hashtag with Astros. We'll look at these tweets on a map. I'm going to zoom out here. Okay, here we go. And I'm trying to scroll in faster, but I'm working with the touchpad, so bear with me. But you can actually see exactly where he was sitting in the stadium when he made these tweets about the Astros. So, if you're ever wondering what he was thinking while he was watching a baseball game, I'm sure we could look at the date here too. Type in to Google, see what the score was at the time. 209. You can get some pretty creepy things out with publicly available social media right now. So be wise about what you choose to post. We can also view all this information as a chart if we want to. So the way that I put this together, I'm using HiCharts.js, fantastic JavaScript library. Basically I'm just looking at all the passes available. So we have 6 passes available, 9 altogether. It's 6 out of 9, that's 66.67%. So of the passes available, 66% are hashtags, 33% are usernames. You can click on these and kind of drill down and see what was there. If I get rid of these, the chart updates automatically. So you can build some pretty cool web applications on top of MarkLogic to do some pretty not so cool things if you want to. So I've got a semantic demo for you too. I wasn't able to put in visualization yet. It's something on my to-do list. But this is a Sparkle query where if I take my friend's tweets and I run this, it'll show me everyone that he tweets to, or everyone that he's tweeted to in that set of tweets. So there we go. I can also do another semantic query and just look at all the hashtags that he tweets about. Now imagine that we had, DBpedia, we had a larger graph of information and we knew what these hashtags were actually talking about. Maybe we have them linked to Wikipedia pages or something like that. And I could just, extend this query one more node and I could say, okay, what out to view 211, what's this hashtag about? And, we could figure that out easily using kind of document traversal as our graph model. And that's kind of where I'm going with it. But that's really the only thing I feel like I can present well enough about it. So, 5 minutes left? Okay. So I'll open up for 5 more minutes of questions, and I'll let the organizers cut me off when time goes. Yes, sir.
So is there any, feedback loops that can implement some sort of neural network for your semantic? So say subject was Chevy or something, an employee of a Chevy truck. Is there some sort of semantic feedback loop where it's okay, well that's the correct issue that the car had, and it reports back up the line and says yes, that's correct, so increase the probability that that's the correct answer, kind of like how our brains work with neurons.
Yeah, that's absolutely possible, and I think that's what Mitchell 1 does. I'm not too familiar with the details of that account. I also don't know, what the various levels of MBAs are, but my understanding is that they are doing something very similar to that. If people report that it is a problem, then they're going to go look at that piece of data, analyze it, and it's going to become maybe less relevant with search results that come back in mechanics. Other questions? Yes, sir.
When you put the chart for the architecture, I thought that you have on the top SQLs. Are you saying we could get
Yes.
a normal SQL we don't have to use Sparkle?
Yes, absolutely. If you wanted to query this database with SQL, you absolutely could. And the way that works is you look at the document, you put indexes on the document. So you have, maybe a document for people, you have an index on their name, you have an index on their address, and then essentially you just query the indexes. You could say select star from this document type using these indexes, and then your where clause has all those fields available in it.
And it's an ANSI SQL?
Yep, very standard ANSI SQL. So you can join different types of documents together just as you would tables. It's very powerful, and if you're going to use ODBC connectivity, you need to do that kind of work anyways because ODBC relies on SQL.
And you said you could merge non-structured and structured data in here?
Yeah, absolutely.
Okay.
I've done it with other customers before. They have very strict structured data that goes through a lot of schemas before it goes into the database. and then they have very unstructured textual data, and they want to be able to search them across, search across all their data, and it works really well. Yes, sir.
So typically, you discuss some of the use cases. What is your implementation plan in terms of if a company wants to implement something more like semantic-wise, and they already have obviously the relational database stored, would you go through an exercise of first defining those facts and getting those facts through an exercise with them and then putting that data into the database?
Yeah, so it very much depends on how the facts are represented currently and what system they're representing currently. Like we have the facts in Oracle, for example, and we have it very clearly defined that this field should be a subject, this field should be an object, and the join is the predicate or something like that. Then we'll actually write that SQL query, pull that data back, and then we'll use our tool like MLSAM to do this for us, and apply a transformation on that data as it comes back to actually format it into the kind of triple structure that we need from MarkLogic to work with, and then actually ingest it into the database. So there will be a little bit of legwork there. It won't just necessarily work out of the box, but if you have information in a database now that you think fits into the triple format well, then there's absolutely a way to do it. There always is. It may not be instant, it may take a day or two of work, but it's absolutely possible, and that's what consultants like myself are here for. Other questions? Yes.
This might be a little technical. So let's say you have a star schema, right? And that's been denormalized, right? And you have a star schema usually is a lot of facts and then
Right, all in one central location.
and the dimensions branches from there. What's the advantage in using something like this as opposed to star schema?
It depends on your query. It depends on what kind of information you're trying to get out of the data. If you're trying to get information out that's going to be going through a lot of joins in that schema, you might not be seeing the performance that you need, and your use case might be solely based on performance. Or if you're trying to put semi-structured or unstructured data into your schema because you're adding new tables to it, it may be a better choice to use MarkLogic to store that data and just have the two talk to each other over the network, because MarkLogic will give you more query capabilities on that unstructured information. Or semantic data, for example.
And do you have to suck the data out of the two data sources and put it in the third repository for MarkLogic, or does it do data virtualization?
Yeah, you have to suck the two out and essentially ingest them in MarkLogic. What I've seen other customers do is I've seen them just take the metadata out instead of the data, and then they lower their storage needs by just ingesting the metadata, because the metadata will include references to where the data actually lives on the source system. I've done that with like SharePoint, for example, before. I've just said, okay, if you want the SharePoint document, we won't store it, we won't ingest it, but it lives here, and we have enough metadata, and we have the triples about it, we don't need to store the whole thing. Any last questions?
You can share the D3JS example.
I can't, it's for a company that I can't share, I'm sorry.
Okay, but where is that, is there an example?
Oh yeah, an example out there. So there is a gentleman on GitHub. I don't know if I can find it right now, but I'll make sure that I give it to the presenter so that he can share it with you. But I think I know his name, but yeah, I'm pretty positive I've seen it on GitHub before, so.
You've got another question back there.
Oh, yes, sir.
We're still good.
So you're talking about the Java Spring Framework, correct? Yeah, so our default stack that we recommend to people for developing applications actually includes Spring in it. So if you're doing some development work with Spring, then we're totally Spring supported. So.
Is there Spring templates? What is the...
I'm not a very extensive Java developer, so I don't know if I can speak to features like that, but we have an application on GitHub called Sample Stack. There's a Java version of it and a Node.js version of it. I know for a fact that the Java version is using Spring. I don't know which features are being used, but I can't think of any reason in my head why you couldn't use every feature of Spring unless there's some very SQL-oriented feature or some kind of SQL class that only is built to connect relational databases within Spring.
No, that's not.
Okay. But anyways, if you want to try to solve...
I was just asking, is that support for any other JNS support for MongoDB? So, it has Spring templates for those types of data stores.
Oh, okay. I don't know if we have a template offhand. The sample stack that we have on GitHub probably the closest you can get to it. And we do have a Java API that connects natively, and our sample stack will include examples of doing that. And by the way, before I forget, I did have one last slide, which I'll just finish with. But please, we have MarkLogic World Tour. We're going to be in Houston on July 16th. Come meet with us. Come meet with our clients. I have some pamphlets and brochures and business cards over on my desk. If you'd like anything, I also have coffee mugs, and they're going fast. So please grab them so that I don't have to take them back on the plane with me. And you know, our software is free if you'd like to try it. It only costs money if you're going to use it in production. You know, any questions at all, please see me later. So thank you so much for your time. I really appreciate it. Thank you so much for your time and attention.
This is great. Thanks a lot. This is really informative. This is part of the reason we're trying to do this. Is a whole different view of the world of the semantic web. It's a whole different view of how you can use this technology. We're going to take about I'm going to say about a 15-minute break. If you look at the schedule, we had a 15-minute break. So we're going to set up for the next speaker.
Thank you so much. I really appreciate it. It was great to be here. Oh, absolutely. I was told by my director and some other people that, you know, you want to go right on semantics and not get into the reason much. And I'm like, are you kidding me? This is the best part. Thank you. I really appreciate that. Thank you. This is my first time doing a really big presentation like that. Thank you. I didn't get it. Hi, Paul, I know you're going to take over the next session. Yeah. Can you give me a rundown on what your session is?
It's healthcare to Hadoop, Storm, Kafka.
So it's going to be all hands-on, or it's going to be some theory?
No, it's going to be both. It's going to be section in the middle will be hands-on, and you can go kind of as far as you can. Cover Spark at the end.
Okay. That's always the biggest problem, right? You start with like some problems, and every now and then you find that one problem. We are all interested in Spark. Okay. Spark. Tell Spark, did you see the announcement that IBM did?